Alright guys, this is video 6.2, Properties of Parallelograms. Alright, here's your vocab, make sure you write these down. Parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. I'll show you a picture in a minute, explain it. Consecutive angles are angles in a polygon that share a side. Again, I'll show you a picture in a minute. Make sure you write these down, pause the video till you have these written down. Okay, so here we have a quadrilateral, okay? In this quadrilateral, if you knew that this top side here and this bottom side here, okay, were parallel, all right, so let's put two little dash marks or two little arrowheads to indicate parallel, okay. Now, since these two sides do not touch, these are referred to as what's called opposite sides. Opposite sides do not touch, okay. So if you knew that these two sides are parallel, and then the left and the right side as well, if you know they were parallel, okay. So we have a quadrilateral. Opposite sides are parallel. That makes it a parallelogram. Okay, that's all a parallelogram is. You have some kind of quadrilateral with opposite sides parallel. Now, in a parallelogram, the opposite sides are not only parallel, but they're congruent. So let's put our congruent marks as well. Okay, so parallelogram, both sides are parallel. Opposite sides are parallel and congruent. Okay, parallel and congruent. Now, let's talk about the consecutive angles part. Okay, with consecutive angles, remember, they're angles that share a side. Okay, so if we were to label this A, B, C, and D, okay, consecutive angles would be like A and D. Okay, A and D are consecutive angles because they share a side. Okay, so angle A and angle D are consecutive angles. Consecutive angles. Okay, A and B are consecutive, C and D are consecutive, B and C are consecutive. Okay, angles that share a side are consecutive angles. Now, in a parallelogram like we have here, I'm telling you this is a parallelogram. Okay, in a parallelogram, consecutive angles are supplementary. Okay, consecutive angles are supplementary, meaning they add to 180 degrees. Okay, so the measure of angle A plus the measure of angle D equals 180 degrees. Okay, consecutive angles will always add up to 180 degrees. Okay, they will always be supplementary. Now, opposite angles. Okay, opposite angles do not share a side. So angle B is opposite D. They don't share a side. Angle A is opposite C. Opposite angles are congruent. So B is congruent to D, and A is congruent to C. Make sure you write that down. Opposite angles are congruent. Opposite angles are congruent. I abbreviated there. You can abbreviate too if you understand what all that means. Opposite angles are congruent. Okay, so we know a few things about a parallelogram now. Parallelograms, opposite sides are parallel and congruent. Consecutive angles of a parallelogram are supplementary, and opposite angles of a parallelogram are congruent. Okay, so we know several things right now about parallelograms. Okay, let's do a U try. Okay, so go ahead and write this. Go ahead and write down the question and copy this into your notes and then answer it. So say this side here is x plus 2. This is 127 degrees. And this side is 2x minus 3. Okay. What I want you to do, this is a U try. Find the value of x. Okay, so go ahead and pause the video and find the value of x. Now this is a parallelogram. Okay, so pause video, find the value of x. Okay, so hopefully you found the value of x. What you're going to have to do, since we know opposite sides of a parallelogram are congruent, we know then, let me pull this down a little bit, we know then that the x plus 2 is going to equal the 2x minus 3, and all we have to do here is solve for x. Okay, so subtract x plus 3 plus 3, so 5 equals x. Okay, all you gotta do is sub it in to test it out. 5 plus 2 is 7. 2x is 10 minus 3 is 7. They both equal 7, so therefore we know we did it correctly. Alright, so a few things. Parallelogram, opposite sides parallel and congruent. Opposite angles congruent. Consecutive angles supplementary. Okay, this isn't a U-try, but let's just think about it. If this is 127 degrees, what's this angle over here? We'll call it Y. If you said 53 degrees, you'd be correct, because 53 plus 127 is, of course, 180. Okay, that means this angle, 53 degrees, and this angle, 127 degrees. Okay? All right, let's keep going. Now, something else about a parallelogram. Okay? The diagonals. Okay, the diagonals connect the opposite vertices. Okay? Let me draw them in. All right, here's one diagonal, and then here's the other diagonal. Okay? The diagonals of a quadrilateral bisect each other. Okay? So we'll call this A, B, C, D, and we'll call where they cross here E. Okay? We know that BE is parallel to ED because we know they bisect each other. We also know that AE is congruent to EC. Okay? So the diagonals bisect each other. All right, so if we knew BD was, say, 12, and asked you for BE, well, since we know that they bisect each other and we know both sides are congruent, we know that BE would be 6 because it simply be half the length of BD. Okay, so let's throw in another U-try. Okay, now this U-try is dealing with the fact that we know that the angles, I'm sorry, that the diagonals bisect each other. Okay, all right, so here we have a parallelogram. Let me draw in the diagonals. Okay, say this is 3y minus 7, this part of the line right here. This is y, this is 2x, and this is x plus 1. What I want you to do is find x and y. Remember, just put this in your notes. Whoops. Find x and y. So pause the video, find x and y. All right, so if you notice here, we know that they bisect each other. So we know that the 3y minus 7 equals 2x. And we also know that the x plus 1 equals y. Okay, but if you look, we have two variables in each of those equations. So how are we going to solve them? Well, if you look over here, we know that 3y minus 7 equals 2x. Over here, we know that x plus 1 equals y. Well, if you notice, we have what y equals. Y is simply x plus 1. So what we can do is we can take this x plus 1 and substitute it in for the y. So our new equation is 3 times x plus 1 minus 7 equals 2x. Okay, because we know that y is 2x plus 1. That's what this tells us right here. So we can take that x plus 1 and put it in for the y. So now we only have x's. We can solve the equation. Okay, so 3x plus 3 minus 7 equals 2x. So 3x minus 4 equals 2x. Okay, subtract 2x, subtract 2x, add 4, add 4. So we know that 3x minus 2x is x equals 4. Okay, I know it's kind of diagonal. I'll fix that here in a second. So we know that x equals 4, and we know that y equals x plus 1. So that means y equals 4 plus 1, or y equals 5. Now, after you find x, it doesn't matter if you plug it into this equation or this equation. Okay? Either way, it's going to give you the same answer. What I suggest doing is plugging x into the equation you find the easiest. Okay? If you think this one's easier, plug it in here. If you think this one's easier, plug it in here. Doesn't matter which one you use, they're both going to come out the same. And the only reason I say pick the easiest one is so you're less likely to make a mathematical error. Okay, you're less likely to make a mistake if you pick the easier one. There's nothing wrong with picking the easier one. Hey, it's what I do, and I teach this class. Okay, so just pick the easier one, plug it in, and solve. All right. Okay, so now when you have multiple parallel lines, okay, say we have this line, and this line. So we have 3 parallel lines. Okay, 3 parallel lines. Let me mark them parallel. 1, 2, 3. So we have 3 parallel lines. Now say there's 2 lines that cut these. Like this line here, and let's do this line here. Okay. Now, if we knew that this segment here is congruent to this segment here, okay, we automatically know because of that, okay, we automatically know because of that that these 2 segments over here are also congruent, okay? Because if these lines are parallel and these 2 segments are congruent, that means that these lines are equally spaced. So at that point, any line you draw through here that cuts all 3 of these, the segments in between are all going to be congruent. So if I added another one, say coming across, I'm going to make it come across real big. Coming across like this, okay? I would know, based on this alone, this congruent to this, I would know that this segment here is also congruent to this segment here. Okay, again, because parallel lines, if they're cut by a transversal, and the segments of that transversal are congruent, then every transversal that you draw through those parallel lines, the segments that the parallel lines cut the transversal into will always be the same length. Okay, and it doesn't matter if your parallel lines run horizontal. I could also come over here and draw them vertical. Doesn't matter. Okay, there will always be, and it doesn't matter how many you have. Say I had 4, okay, and all 4 of those are parallel, and I had this line coming through here like this line coming through here like this. All right, we know these are parallel. All right, we know those are parallel, and if we know that these 3 segments are congruent, we automatically know that these 3 segments are congruent as well. Okay, it's just some properties of parallel lines, guys. All right, so parallel lines, if one transversal, the segments are congruent, any transversal, the segments will be congruent. Okay, so let's look at this. I'm going to erase this. I'm only going to give you this information. Actually, no, I'm going to erase this too. All right, say we have this diagram. We have 4 parallel lines. Say we know that all 3 of these segments are 8. All right, that's these horizontal segments here. If this segment was, say, 9, what would x and y be? Okay, it's kind of a short you try. Pause the video and think about it. What would be the value of x and y? All right, if you said x and y would both equal 9, you are correct. Because like I said, when you have parallel lines, okay, and one transversal is cut into congruent segments, every transversal you draw through there will be cut into congruent segments. So 9, 9, and 9. 8, 8, and 8. If I drew another line through here, all three of those would be congruent as well. Okay? It's just some properties of parallel lines, guys. All right? So, this concludes the video. Here is your ticket in the door. Make sure you write these questions down. Okay? Write them down in your notes. I'm sorry, don't write them in your notes. Write these on a separate sheet of paper. Don't write these in your notebook. Write them on a separate sheet of paper. And when you come in tomorrow in class, I'll have the answers on the board. Check them. If they're right, turn them in. Awesome. If you missed a couple, see if you can figure out what you did wrong. Okay? Fix it. Turn it in. If you have to, you can ask me, and I'll explain it for you. So number 1, it says use parallelogram ABCD to find the value of each, to measure of angle A, the measure of angle D, x, and the length of AB. Number 5, what are ED and FD in the figure at the right? So it wants the length of ED and the length of FD. Okay, number 6, if you know one angle measure of a parallelogram, how can you find the other 3? What is the difference between a quadrilateral and a parallelogram? And number 8, your classmate says that QV is 10. Explain why the statement may not be correct. Okay, explain why it may not be correct. All right, so make sure you write these questions down on a separate sheet of paper from your notes, answer them, and bring them to class tomorrow. See you tomorrow.